Hello everyone. In this video, we will be talking about NumPy. As we all know that NumPy is one of the Python's package which is used for doing the numerical calculations. So in this video, we will discuss in detail about some of the NumPy operations, like how we can create NumPy arrays, then what are the sampling methods, what are the how we can create the different mathematical operations, uh, math operations, as well as some of the linear algebra operations. So let's start. So before starting, it's important to check that whether NumPy is installed in your system or not. So you can just go to your Anaconda command prompt, just type this command pip install NumPy. You can also put it inside this Jupyter cell, but before you can just put this kind of an exclamation mark like this and run this. So it will install the NumPy in your notebook. But if you want to do it in your Anaconda command prompt, just type pip install NumPy. But in most of the scenarios, Anaconda comes with NumPy, so you don't need to install it separately. So the next step is once we are sure that NumPy is installed in our system, we can we can check that we have to import NumPy. So import NumPy is basically telling Python interpreter that we want to use the NumPy package. So for if we want to use any package in Python, we can do that by using the import keyword. So we can say import NumPy as NP. So this is going to import the NumPy package, and we are going to use the abbreviation NP for accessing the NumPy. So I'm going to run this one. Now let's start with the creation of arrays. So we all know that NumPy provides the support for creating a one-dimensional as well as two-dimensional arrays. So we will see that how we can create one-dimensional arrays. So we can create a one-dimensional array by using the np.array method. Okay. So here, when we talk about one-dimensional arrays, it is also called as vectors. So I have given a name VEC, a short abbreviation for vector is equal to np.array 123. This is going to create a array of 123. We can also create multi-dimensional arrays by converting the lists of list. So multi-dimensional arrays are also called as matrix. So we can use the same np.array method, and we can see there are three lists, and these three lists are combined. So to create a kind of a matrix. So this is the multi-dimensional array. We can also create arrays using the arrange method. So arrange method, we can specify the range like from 0 to 15, and it's going to create a array for us. So we can see from 0 to 15. So the last number is not being included. 15 is not included. So it starts with 0 and it ends with 14. Arrange method, we can also provide the step size, if we have provided here from 3 to 21, but with a gap of 6. So it's going to create the elements 3, 9, and 15, and all of three have the gap of 6. So step size is 6 here. The other method is the linspace method, which we can also use for creating the arrays. So here we can also specify the range from 0 to 5 and then the step size. So it's going to create the numbers accordingly. Then the most important feature, one of the most important feature of NumPy is NumPy arrays is that we can reshape it. We can reshape the size. Like if it's a single dimensional, we can convert into a higher dimension. So let's say this is the vector 4 which we created here. So it's a kind of a single dimension, but we want to convert it into a kind of a multi-dimensional. Like it should have 5 rows and 2 columns. So we can use this reshape method. So when we run this, we can see this was converted into a kind of a multi-dimensional array. So we have 5 rows and 2 columns. Similar way, if we want to convert a higher dimensional array back to a single dimension, so we can use this dot ravel method. So it's going to flatten the array. You can see the array is now converted back to the single dimension. Zeros method can also be used. So we can use the dot zeros method. Inside this, we can specify 5 comma 3. 5 means how many number of rows, and 3 means number of columns. It's going to create a kind of a matrix which has 5 columns, 5 rows, and 3 columns. We can also use the ones. So it's going to create a NumPy array which has all the ones in its cells. So we have all the ones in the cells, and it's since we have specified 3 comma 5, so it has 3 uh, rows and 5 columns. I method can also be used to create a matrix. It's going to create a matrix which has ones in the diagonal and rest of the values are zero. Now we will look into some of the maths function. So let's create a random number. So I've just used this np.random.rand function. So it's going to create a random number between 5 to 5. So this is the value which is being created. This is the random numbers which is being generated. Now, if I want to do a kind of an element wise addition, subtraction, multiplication. So we can just do this AR plus 10, AR minus 10, AR multiplication 10, AR division by 10. So what will happen? It's going to perform the operations on each of the element respectively. So we can see that. Okay, so we have to run this one. Okay, let me change the array. I think this is not defined. Yes. So now we can get the values accordingly, all of the operations. We can also use the above operation we have used in this way, but instead we can use the built-in methods. Okay. So what's the advantage of using the built-in methods is like it's going to save the memory and already the array gets updated. So no need to create a separate variable and assign it. So we can use the np.add is going to add the values. So what we are doing is we have an array 1, 2, 3, and we have another array 8, 9, 10. So we are adding it using the np.add method. So each element wise addition is happening. 8 plus 1, 9, 9 plus 2, 11, 10 plus 3, 13. Similar way we can do the subtraction. Then we have multiplication. We can also do a kind of an exponentiation. So exponentiation, what it will do, it's going to raise the power. So I have to change this to let me do one, and then I should do it. So this is how we can do it. Another thing is we can also go for natural log. So this is also going to help us. Let me do that. So it's also going to give us the natural logarithm. Natural logarithm means logarithm with a base of 10. We can also do a logarithm with base 2 by using np.log2 method. So I can just do it like this way, and then we can get the values accordingly. We can also perform the square root by doing this, by using the np.square root. And we can also perform trigonometric methods like sine, cosine, tan, um, and cot. All these methods we can do it using this numpy mathematical operations. So we can use the np.sin, np.cos. So let me use the array 1, and it's going to perform the element wise. So there are some assignments, so you can have a look at it of the code. And please always, if you have any queries regarding any syntax, anything, the best is to go to the official website. In the official website, you will find out each and everything in detail. Now, apart from doing the mathematical operations, there are some sampling methods. Now, when I say sampling methods, it's which means that we can create a kind of a random data. Okay, so how we can create a random data using the np.random method. So np.random contains a lot of methods, like we can have the rand. Okay, so we can create a kind of a random methods. It's created a kind of a random methods. We want three random numbers. It's going to create three random numbers. We want to create a kind of a two-dimensional arrays. Okay, using 3 rows and 3 columns. So it's going to give us it will generate a random number using this. We can also generate a random a set of numbers, or we can say a set of random numbers which are standard, which has a standard distribution. Or when I say standard or normal distribution, which means that those numbers have a mean of 0 and variance of 1. We will look into all these concepts in detail when we'll be discussing about statistics. So by using this rand method, okay, simple rand method will generate the number randomly, but rand method is going to generate the number randomly, and those numbers will be normally distributed. So normally distribution means that mean is equal to 0, variance is equal to 1, standard normal distribution. Now we can also do it like we can also create a kind of a random integer. So rand integer, so it's going to create a random integer. There are some other methods inside this np.random, like we can create a random sample. We can use this dot random method, around ranf method, okay, and dot sample method for creating it. So this way we can create a random numbers in a using the numpy. So we can create numpy arrays which with random values in so many different ways. Now there are some assignments, like you can find it out on yourself, like how to generate a random sample from a given one-dimensional array, how to shuffle the values of the array, how to calculate the permutation using the array. Now let's look into some of the linear algebra. So we know that NumPy provides us the facility of creating a one-dimensional array and a two-dimensional array. So one-dimensional array is basically called as a vector, and two-dimensional array is also called as is called as a matrix. Now we know that in our schools we have studied about the matrix multiplication, and how we can perform a multiplication between a matrix and a vector and two different matrix, okay, all those things we have seen. So those things we were doing it manually, but with the help of numpy it saves time. We can just directly use the uh, linear algebra methods of numpy, and we can perform those operations. So we can do a matrix multiplication. So here we have a matrix, okay, which is a 3 cross 3 matrix, which has a 1 2 1 4 5 9 1 8 9. So this is the matrix which we have, and then we have a vector 1 2 3. So when we do the multiplication, so this is our result, 8 41 and 41. This is our result. So we can perform by using the np dot mat mul, which is a short abbreviation for matrix multiplication. So this way we can perform the matrix multiplication. We can also perform the linear algebra, like we can go for the inverse of the matrix. We can perform the solve. So by doing this, please don't worry about the matrix multiplication and all those things. This session is only about numpy, that what are the things which we can do with numpy. What is the depth of these mathematical concepts? We will discuss it in our coming modules in detail. We can also perform QR factorization. We can do this QR factorization by using the np.linear linalg, which is a short abbreviation for linear algebra. So np.linalg.qr and array. So we are going to get this QR factorization. We can also go for singular value decomposition. So by using this linear algebra dot svd, svd is the short form of singular value decomposition. The other method is like we can compute eigenvalues and eigen decomposition. So these all concepts, singular value decomposition, eigenvalues, eigenvalue decomposition, these all we will be discussing when we will be discussing about some of the machine learning algorithms. As of now, eigenvalues, and just try to understand in a very rough way that eigenvalues and eigen decomposition are one of the mathematical concept which is used when we are discussing principal component analysis. Principal component analysis is a machine learning algorithm, okay, for dimensionality reduction. So I'm not going to go into the depth. And similar way, singular value decomposition is being used when we are building the recommendation system. It helps us to find out the relationship between two articles. Just a rough idea about what are these things. Okay, then we can create the eigenvalues. We can create the eigenvalue decomposition. We can also create the determinant and the trace of a given matrix. So we can do that, and we can also create the determinant. So this was all about NumPy. Please practice as much as you can. That's what I would suggest.